In this video, we're going to be talking about linear regression. Alright, so the idea behind linear regression is that we want to fit a line that best represents the linear relationship between two numerical variables. Here we're going to just focus on two numerical variables. Later on there's kind of extensions to make it so that it doesn't have to be numerical variables. You can use categorical variables. For now we'll just focus on numerical variables. Alright, so here's just kind of the graphical representation of the relationship between these two variables. Here we have a data set with cars, and we have the car's horsepower and the miles per gallon that car gets. And so you can kind of see some sort of trend here. It's basically as the car's horsepower goes up, looks like the miles per gallon kind of roughly goes down. So what we want to do is we want to basically fit a line that best represents this linear relationship between these two variables. So when fitting a regression line, we typically have one variable as our outcome variable, y variable, dependent variable, and another variable as the predictor variable, so the x variable or independent variable. So depending on the field that you're in, or just kind of where you are, basically there's different names for essentially the same thing. So some people call it outcome variable, some people call it dependent variable. So these are all just kind of different names for the same thing. So the outcome variable is typically put on the y-axis, and the predictor is usually put on the x-axis. And so really the idea is that you're going to use that x-axis variable, the predictor variable, to predict the outcome, the y variable. So in the case of this horsepower and miles per gallon, we're using the predictor horsepower to try to predict a car's miles per gallon. And so this blue line is really what we want to try to fit, right? So basically, we want to find this line that is, that best fits these data. And so to do that, what we're going to use is something called least squares regression line. And basically, this is the line that minimizes the sum of squared vertical distances between the data points and the line. And so to just kind of show a graph of what that looks like, basically this blue line is kind of a perspective line that we might have for this best fit line. And these dashed lines are the kind of vertical distances of all the data points to that line. And so what we can do is we can square all of these distances, add them up, and that's our measure of our sum of squared errors, our sum of squared residuals. So basically that's kind of like our error, and we want to try to minimize that value. If we have a blue line that's really far off from all of these points, then these dashed lines would be much longer. Squaring them and adding them up together, we may need a much higher error. And so we just want to find that line that minimizes this sum of squared errors value. Right, so once we've found that line, what are we going to do with it? Well, finding this line can actually give us a few different things, actually. So one is that we can kind of take that slope and interpret it. Basically, if we have a significant slope, whether it's positive or negative, that tells us something about these two variables. It tells us that there's a relationship. So for example, with horsepower and miles per gallon, it tells us that there's a significant relationship between horsepower and miles per gallon, namely that as horsepower goes up, the miles per gallon of a car goes down. And also another benefit of using this regression line is just to get predictions out of it. So basically, instead of just finding relationships, we can take future data and make predictions about the future. And so here again, this is the blue line, the least squares regression line for predicting miles per gallon from horsepower. So for example, let's say I have this, and then I got a new car that had maybe around, let's say it had around 200 horsepower. So you might not exactly be sure about how much miles per gallon it would get, but using this regression line, you might say, okay, so I might predict this to have maybe 16, 17 miles per gallon, just based on this regression line, just because that's the relationship, and we have this best fit line. We might be off by a little bit, but that's kind of a pretty good guess as to what the miles per gallon of that car would be. And so really that's the idea behind predictions. We can use this line to make predictions about the future.